Hello, my friends. Thanks for joining me this week here on Origins. My name's Don Chapman. Now, we've been taking evidence. You say there's somewhere between 100 and 200 different ways that we can look at things that would measure in some way the age of the universe and the age of the Earth.
Mm-hmm.
And you took 14 of those key ones in an article that you wrote some time ago. Will you remind us of that article?
Oh, sure. Let me show you a picture of it. This is an internet article, and it documents 14 items of this young world evidence. And I did it for the Institute for Creation Research in June 2005. And you can find it on icr.org, and it gives you references.
Now, on a previous show, we listed, I believe, 9 of the 14 evidences that you have in that article.
That's just a sample.
That's some incredible samples. And I urge the people to remember the preponderance of the pile of the evidence, not just the individuals. But one of the things that at the end of the show you said that it was like 90-10, that you believe 90% of the evidence hinted towards a young Earth, but there was 10% of the evidence that maybe hinted at an old Earth. But today you want to speak to those issues that were in that 10% category.
That's exactly right.
And I'm excited for you to do that, especially this first one that talks about carbon-14.
Right.
Everybody tells me you can take carbon-14 and you can date the Earth and you can find out it's billions of years old. What do you say to those folks?
Well, I say carbon-14 has now turned around, and we use it to show the world is not billions of years old, but only thousands. It's become the friend of creationists. So
we'll be anxious to see your evidence for that, because there's a few skeptics out there right now when I just heard you say that. So please share. You've worked in this area pretty extensively.
Yes, on the radioisotopes and the Age of the Earth project, I was a co-author with Dr. John Baumgardner and several other people on carbon-14. And so one of the shocking things that most people don't know, and they don't know why it's shocking yet, but is that all fossils have young carbon-14 ages. Now, if you don't know why that's a shocker, I need to explain. This is from standard radiocarbon journals. And things like coal, wood, shell, bone, marble, natural gas, CO2. This is from standard journals that deal with carbon-14. And they all found carbon-14 in them. So they're radioactive. Now, carbon-14 decays pretty fast. It's got a half-life of only 5,700 years, a little less than 6,000 years. So after 1 million years of decay, there would be no carbon-14 atoms left in any fossil. Yet all these fossils are supposed to be older than 2 million years, and a lot of them hundreds of millions of years old. So it was a trade secret of the radiocarbon community for many years that this was happening. But it turns out that it really supports a young world. Conventional age is millions of years. The standard carbon-14 age of all of these is less than 70,000 years, and the average is about 50,000 years. But when you correct the assumption that goes into carbon-14 for what the Genesis flood did to the situation, then the age drops to about 5,000 years.
That's amazing.
Yeah, carbon-14 is now the friend of creationists.
That's amazing. Now, diamonds play a part in bringing this all to the head as well, don't they?
Yes, that's right. It has to do with the excuse that people use. All the labs assume that somehow modern carbon was getting into the fossils, and that has a lot of carbon-14 in it. So we tested that assumption with the diamonds, like you're mentioning.
So, in other words, the explanation they would give for the carbon that was there is that somehow a new carbon was getting into the old fossils.
Say, fungus got into the coal somehow. And
but you found the hardest thing you could find where there couldn't be contamination.
Right. Diamonds.
And what did the diamonds teach us?
They have young carbon-14 ages too. Nobody had ever measured diamonds.
Wow.
Because you can't contaminate them internally, so they wouldn't expect any carbon-14 to get in from the outside. And the labs don't contaminate them externally. They've taken great precautions not to do that. And we use the world's best carbon-14 lab, and its specialty was small amounts of carbon. And they had 20 years of experience. And these things are from the depths of the Earth, which are supposed to be billions of years old. So the conventional age for these diamonds was between 1 and 2 billion years, dated by other methods, other radioactive methods. But the carbon-14 gives you an average of 58,000 years. That's the standard, and we think the assumptions on that are wrong. If they're corrected, we think that it's probably less than 10,000 years. Now, the other side came up with a thought that underground neutrons are somehow generating carbon-14 in the diamonds, and that was a good theory, but the problem is the measured amounts of underground neutrons are too low. And so helium leakage from radioactive zircons deflates the billions of years. This is the next item, on item 10. At a well in Los Alamos, New Mexico, researchers there recovered some microscopic crystals of zircon. That's zirconium silicate. It's in almost every granite there is. And all of these contain uranium. When zircon forms, it grabs uranium from the surrounding lava, and it rejects lead. So it's an ideal lab for radioisotope studies, or radioactivity studies. So we noticed something about the helium that uranium decay makes. It makes helium as well as lead. You've heard of alpha decay?
Yes, sir.
Yeah, alpha particles are helium nuclei. So when a uranium atom decays, it spits out an alpha particle, and that stops somewhere and grabs 2 electrons and becomes a full-fledged helium atom. And in the size zircons we were looking at, a lot of them would stop, the alpha particles would stop inside the zircon. So I'm going to show you how many helium atoms a uranium atom makes as it decays down to lead. So we'll count them. 1, 2, 3, 4, 5, 6, 7, 8. So if we know how much lead is in a crystal now, we know that that crystal, from experiment, we know that zircons don't like lead, so they will reject it when they're forming. So if you know how many lead atoms are in the crystal, then you know how many helium atoms were deposited. And that's important. Now, another thing you can do is date this from looking at the lead and looking at how much uranium is left and taking today's decay rate, and you will get a date that way. And you get 1.5 billion years, which is consistent with evolutionary ideas about the formation it's from. So now that helium leaks. It's known that helium wiggles through a crystal and out into other surroundings. Leaks into the mica that surrounds it. Mica is that flaky, shiny stuff in granite, into the mica, which is called biotite. So the helium leaks out. And usually it leaks pretty fast. So it was surprising to find so much helium still left. Now the question is, how much is left? So here's the depth in miles. 0.5 mile down to 2.5 miles, and the temperature gets hotter and hotter, up to 277 degrees centigrade. That's hotter than your oven gets. And here's the percentage of the helium that we know was deposited that's still in those crystals. 80% in the top, and then it diminishes down to 0.1% at the bottom. 58%, 42%. That's a lot of the helium that's left, and this surprised everybody who heard about these results the first time it happened. So we duplicated those results, but this time we wanted to find out how long it would take for the helium to leak out. So now I'm going to do a graph. And I know a lot of the audience is afraid of graphs. Are you afraid of graphs?
No,
okay.
I've never been bitten by a graph.
Okay, that's a good attitude. Graphs are our friends. So, but I'll show you, set up the graph. We're going to plot leak rate versus temperature. So along the bottom here is temperature, and I'll just show which way temperature goes. It gets hotter moving this way, and the color gives you a clue. And then the leak rate is vertical, faster and faster as you go up, and this is a tremendously compressed graph, a factor of 1 trillion from top to bottom. We used the data about how much helium was left to make some predictions about how fast the helium would be leaking when we measured it. And so we made predictions based on either 6,000 years here or 1.5 billion years. And of course, the 1.5 billion years would have much lower leakage rates because it has to stay in the zircon much longer. So now I want to show you the data. I want you to see this because this is, it's very surprising. I don't know of any other way to convey the surprise than to show the graph. Okay, here are the percentages. 42, 27, those percentages in the table I showed you before. And that tells us how much helium was lost, and if it was lost in 6,000 years, you would have these diffusion leak rates. Technical name is diffusion, the real name is leak. And if it was slower in 1.5 billion years, then the leak rates would be much lower. So there's a factor of 100,000 difference between these numbers and these numbers. And we predicted this in print in a book that was published in 2000 AD, before we had any measurements made. And then we got some measurements made. We commissioned helium leak rate experiments. This is the borehole, what comes out of the borehole. It's about this big around. Ground up the rock, extracted the zircons, put it in the, we didn't put it in, the experimenter we got put it in. And he was an evolutionist, and we went through an intermediary, so he didn't know he was doing creationist work. And we can compare the measured rates that he got with the predicted rates that we made. So here's the prediction again. And here are the data.
Wow.
And they fell right on that.
Perfect on the line.
Yeah. So anybody who's a techie says, wow. And that's what I said when I first saw it. In fact, I didn't believe it at first. I thought I'd made some mistake. So it really resoundingly verifies the 6,000 year prediction.
That's amazing.
And it really rejects the 1.5. So this is the data, the blue dots lining up with the red, and it just completely rejects the other model. I've never seen in my scientific life anything that badly rejected or that
It's such a perfect line,
accepted.
it's amazing.
Yeah, the leak rates are so high that the zircons have to be very young. So we took the measured losses and, in effect, the math is more complicated, divided by the measured leak rates, and we got a date for it. And it's 6,000 years, give or take 2,000.
Plus or minus, yeah.
And that's just amazing to me that we would get this. But yet, the same zircon gives you 1.5 billion years when you use the conventional uranium to lead dating. So that says that God must have speeded up radioactive decay during that period. And a lot of other lines of evidence from the radioisotopes and the age of the Earth group show the same thing.
I hope you enjoyed this video. Please make sure to hit that like button, it really does help, and subscribe if you enjoy the content and want to see more, and find more of us on our main channel on Team Standing for Truth. This is Matt Man. Until next time.